Hi everyone, today we're with Neme. Neme, could you introduce yourself and explain what you're going to demo to us today, Kasal?
Hello. Hi, Lara. Hi, Maria. Uh, Neme Tohmé. I'm a data and AI strategist based in Zurich, Switzerland. Mainly, I help customers on their different uh, initiatives when it comes to data and AI. I try to focus on how can we get value out of that. And today, I'll present to you Kasal. Kasal was mainly a project of. It started with we have an experience of building agents, and agents are doing different tasks. And oftentimes, to build these agents, you need a lot of technical background to understand how to build those agents, create those different integration within your ecosystem. And Casal is a solution that helps you to build agents without being technical. And if you have a business background, you're trying to solve a business problem, how can you do it in a simpler approach? So that was kind of the goal of it. So we help to drive initiatives with our customers, and one of that big motivation is how can I allow my business stakeholder to be able to build agents that will help them in their day-to-day activities. So that was kind of the idea behind Kasal. And today I'll be talking a bit about the principles, core capabilities that I was looking into, and demo the Kasal.
Awesome. So can you deep dive a bit more into what it is, how it works, what people can do with it, and like who's the ideal user of Kasal?
So just looking back, we've been the traditional ML. I can look at it as from today. It's in the lens of a tool that it is more. It started rule based, and then we ended up mainly optimizing for a score. And then 2022 was the birth date of generative AI, and that tool is mainly, think of it as the agentic AI approach, which is the convergence of what you have in terms of traditional ML and the generative AI going into that agentic approach. So in terms of what the capability of this tool is doing, it is mainly think of it as autonomous agents. So you're empowering those agents to take decision making on your behalf by making sure that there are some guardrails in. You're mainly making sure that you're augmenting those agents with information. That could be by calling our Genie, for instance, gathering information from Genie. Um, Another core capability within the solution is being able to integrate with other systems around. So you have an ecosystem, you might have an API call, you might have to do an internet search, you might want to be able to connect to an API that gets you the weather or many other APIs that are solving discrete problems. And that becomes important whenever you're talking about information augmentation and ecosystem integration. Agents are like, so I was using this example on Monday. Uh, think of it as from the early days of traditional ML, this was an embryo up to the burst 2022. And then as of now, agents they start crawling, they then start to walk, and then they start to run, and then they start to do a lot of different capabilities. And when you look at the tooling that you could empower the agents, think of it as those are the capabilities that you're able to have on that agent. So it becomes important that your agents are able to understand those different requirements and be able to fulfill those different requirements. So that becomes important to integrate in the ecosystem and augment that data, de-risk the decision making that you're trying to do. Another capability is goal management. So mainly, you could have not just one agent doing one task, but then you could have many different agents and every agent doing multiple different tasks. So how do you make sure you have goal management across the task level, across the entire plan that you're trying to achieve? So I'm querying some data from Genie, for example. I'm looking at the different tables, and my goal is I want to improve the sales pipeline, or I want to look into a marketing Genie space, and I want to be able to identify the effective campaigns. So now we're shifting away from a question answer into a goal that we want to achieve. And that goal is effective campaign identification, which could be a series of questions you want to ask Genie. But imagine you're mandating that goal to the actual agent, and the agent is empowered to ask Genie across all those different questions, and then in the end provide you a sort of report. That's what I would like to do in that sense. So goal management becomes important at the task level, because if the task is aware of the global vision that all the agents is going to achieve, then they will dance together. There will be a formation in every task that is happening across the different agents. And that becomes quite important there, because otherwise you will be in a dissonance. You don't know, you're doing that one particular task, but you're not thinking that I'm going to hand it over for another agent that actually wants to achieve that XYZ vision that those series of agents are able to do.
High level should be this overarching goal. Is it generic?
How high level in terms of so think of it as when you're defining a particular agent, you're providing information that what is the name of the agent, what is the role of the agent, what is the background of that particular agent. And when you give the goal of that particular agent, what's happening is that you might have an agent that is a coordinator that is planning all the different tasks across many other agents. And in terms of how every task is going to be triggered, then that one agent at a high level is going to enrich the context of every single sub-agent that is going to continue on that sub-level. So in terms of now you have one agent that is an orchestrator across all the different agents. And then let's say you're supposed to search, you have a task that goes to search the internet. This big goal is going to enrich the context of that task that is going to search the internet. And that is going to be an additional context that is enriched on that small task of searching that internet. So that's in terms of the hierarchy of how that will. I think once I demo it, you will have a better feel on that. Because again, important to note, and this is something that mainly I covered in some of the slides I had in when I talk about Kasal. At the core, at the nucleus part, so there's LangChain being used. On top of that, we have Crew AI. So I leverage a lot of the capabilities that Crew AI is doing. But in terms of how can I build those different agents, I'm making that front end, back end to make it quite simple to implement. So it's a lot of abstraction on open source projects that are already being used.
Is there any reason you chose LangChain specifically for this?
So mainly I chose Crew AI, and Crew AI was using LangChain in that one. So mainly Crew AI was I was looking into different the solutions that were out there. So you had the Llama Index, you had the LangGraph, you had the Crew AI. And for me, Crew AI was the most natural way of thinking of how agents are doing tasks. So if you think of it, agents are the who, and then task is the what. And you could have a team of agents that are doing, I don't know, brand identification for a marketing department. And then
I think this space is also like evolving so rapidly. So when you choose between one, I think you should also bear in mind it's going to change very quickly anyway. So it's
absolutely good. Absolutely. And abstracting is really nice, because if you build on principles and you can abstract away, that makes it also simple to see, look, there's another approach which is solving a critical problem. So how can you decouple yourself and still be abstracted and achieve the goal that you want to have? Yeah.
Let's jump to the demo?
Yes.
All right, excellent. So let me go ahead and share my screen. So I'm not super proud of the name Kasal, because Kasal in my local language means lazy.
Okay. I was curious to ask what it is.
Yeah. Uh, yeah, it's a bit ironic, and it's a bit funny in the same way. So I thought I'll keep that as an interim name. Who knows? Maybe that can continue. Maybe not. I'll just it was a funny name. So what you see in front of you is mainly the command and control of what Kasal is. So this is mainly where you're able to define your agents, where you're able to define your different tasks. Where you're able to observe what's happening whenever you're running those different tasks. So if I look at this particular screen on this left side, that's mainly the agents, and then on the right side, these are the tasks. So the agent is the who, and then the task is the what. Now, when you look at the agent, the who, you could see that tasks are only assigned. One task is only assigned to one agent. You can have many tasks assigned to one agent, but you cannot have one task assigned to multiple agents. So there's the ownership, very important, that a task is to one agent. And what you also see is that you have a dependency between the tasks. So a particular task that is run by this agent is going to produce an output. And this output is then going to become an input for that particular task. So if I'm doing searching the internet for particular papers, I want to extract some important knowledge out of that. That task could be searching the internet. That task could be extraction. Another task could be writing a summary report out of that. So let me demo quickly how we could create tasks. So let me actually delete everything. So we could add tasks in either the manual approach. So here we could go for the name of the task, the role, the goal, the backstory. We could also add templates. So your system template, from template, what response you want to get back, how does it look like? And you could assign the tools. So if you remember mentioning the child starting to crawl, run, walk. So those are a lot of different tools that you're having. Now,
just for people who want to build those agents without using code, maybe just quickly mentioning the fact that the reason we want to have several tasks or tools is that it's always better to have lots of very specialized tasks that are really good at doing the one thing, rather than having one big, LLM doing everything at the time. It's a bit similar to hiring one very smart person on your team to do everything, researching the paper, analyzing the paper, but maybe it's better to if you hire several people, one is really good at research, one is really good at analyzing. I think a lot of people who are familiar with agents will know this, but for people who want to experiment without any knowledge of GenAI, that's the reason we have all those different tools.
Absolutely. So if you think of it as, so one important core capability your agent could have is the learning and adaptability. So initially, maybe you might start to use one particular tool, but as you have this feedback loop, then you want to optimize, and you could optimize at multiple levels. You could optimize on the model. So if you're using a expensive frontier model initially, or a distilled model, that might not be the best as you evolve and as you be able to solve those different problems. You might want to have a fine-tuned model that is doing the classification based on the taxonomy of that particular data. And then 1 billion parameter model might be outperforming a very expensive model. In terms of not the tools in that case, in terms of the model selection, you might want to choose a fine-tuned small model. Or if you want to use another endpoint, which is a RAG endpoint that has also some of the data on that model. So you become quite flexible, that you can choose agents you could choose models either at an agent level or at the planning level. And that gives you that flexibility. So in terms of optimizations, you optimize on the tools, because one tool might be good in an early stage, but you want to customize it, you want to add additional validation on top of that, and then the LLM as well becomes quite important there.
So now these tools you just showed, are they pre-created?
So in terms of the tools, there are different types of tools. So yes, you have the pre-built tools that you get out of the LangChain, out of the Llama Index, out of the Crew AI, but also I have my custom tools. So for instance, here we recently announced again, it was still in private preview, the conversational API of Genie. And mainly now the agent would be able to talk with Genie over the API. And that's a custom tool that I've built. Another tool is I want to use also, we have the AI forecasting in Unity Catalog, but also I wanted to use different foundational model time series inference. So I integrated another custom tool for Nixta, for example. I added the perplexity tool that allows the agent to get the summary of the different searches from the perplexity API. So in terms of the tool, you have at one point the pre-built tool based on Llama Index, LangChain, Crew AI, but also you have the custom tools that you're able to build on top of that. And in an organization, you want to be able to have this control of what tools you want to give, what is the compliance, what are the security that you want to pass through. It becomes quite important. And the third type of tool, and that is unfortunately not supported in my solution within Databricks, but if you're doing it in a standalone, you could do it, is the transient tool. And that becomes quite powerful. Imagine you have the documentation of the API, you have the actual API key, and you could actually provide a tool that is going to build the tool on the fly, then call the API.
Oh, interesting.
Go move forward. And that's the transient tool. The transient tool is then mainly, something that you could spin up and allow code execution. So when you're defining your agent, and that's Crew AI capability that allows code execution, you could do it in an isolated, for instance, Docker container, or unsafe. That becomes quite dangerous because your prompt definition might allow you to do some things you don't want to be doing, and then hence it wouldn't be contained within that container. So it becomes important there. And those are the transient tools, which probably you don't want to enable across, but that could be quite useful if you have a sandbox where you have limited risk there.
Okay, so then the tools can be pre-created from the packages we are using. You build your own that map to Unity Catalog tools, I guess Databricks tools, or it can be anything external to Databricks hitting different SaaS services, different APIs, any external service really.
Correct.
And the one you said that you allow the agent to create new tools on the fly. Okay.
Correct.
And then when you were creating the agent template, is there any difference in the configuration of defining an orchestrator agent versus an agent who is just dedicated to a task?
Yes, there is.
Okay.
So let me actually just cover. So this was the manual way of defining agents. But what you could do also is you could generate an agent in a prompt. So let's say now I want you to gather information around agentic AI frameworks. So that is an agent that is going to scout the net to identify what's happening around agentic AI frameworks. You could have another agent. You are doing data discovery within my enterprise data platform, talking to an ontology layer or a semantic layer. So you specify any type of agent that you want to do. So this is the who. And then the moment you be able to provide the prompt, a lot of these mainly selection will be generated for you. So in terms of your organizations, you could even tune it more to, look, I have these tools in my organizations and I want to immediately select them, because that prompt immediately will filter down to those particular tools that I want to have. So now I create that agent. So I have that agent, I could add it on my command and control center. And then I could add tasks to that agent. And tasks can be done the same way, either doing it manually or be able to actually generate it through the AI. So here search on, for example, archive.org, all the recent papers from Feb 2025 on agentic AI frameworks. So here you're doing more specific ask that will then be able to allow the agent to go and do that search, provided you give the right tooling for it.
Amazing. Okay.
And then here, if you look at it, you're able to provide the expected output. So now that agent is going to basically go connect to archive.org on a specific filter, get that document back, read it, and then it provides you a JSON array back. But what is quite important is that, again, this is a capability that Crew AI is providing. You're able to provide a sort of a pydantic object. That becomes powerful because now I have an answer, an output from a task that is typed, and I will not proceed further if that output is not complying or abiding by that particular type that I'm having. And what you could do here is also add conditions on top of that. You could add callback functions on top of that. So what does it mean? It means now rather than just running a task, I could also invoke some functions that are validating what that task is providing. So additional to the solution that we have in MLflow in terms of validating the output based on synthetic data, for example, to get the LLM as a judge approach, I'm even going a step further to go on the specifics of that particular use case. I'm getting links from the archive paper. I want to validate those are valid links. I want to validate the robot that I'm not scraping something I'm not allowed to do. I could add a lot of different conditions there, and those will be blueprints, tools that can be reused by my different tasks and comply within the organization rules, what I'm allowed to do and not.
So what we are referring to is checking each task if it is correct or not, let's say, given some criteria, before it moves on to the next task or before it returns the answer to the user.
Absolutely.
Okay.
And what you could do also is having a human in the loop. So meaning that that particular task identifies, for instance, fraud, and you want to do the next best action by triggering an alert. So before triggering that alert, you need to have a human that allows that task to go forward. And that also becomes important whenever we're empowering agents with decision making. We need to make sure that some decisions cannot proceed unless there's an approval from a human.
Okay, very nice.
So let's say now I created this particular task. So now I have a task that is able to search for the agentic AI. I could just simply double click here and then that task is assigned to my agent. So now what I've done is I created the agent manually through a prompt. I created this task through a prompt. But what if you could actually allow the agents to create the agents? So that's where you have
next level.
Exactly. And that's where I was trying to simplify it for our users. How can they do things simpler? So let's say now, yes, can you get me all the latest papers on agentic AI patterns in February 2025? So I take this now as a plan. I want to then in turn extract all the conclusions from the paper, provide me the source of the paper, also provide me papers with the highest reference. I'm getting complicated here. Well, let's try to generate that plan and see what's happening. So now I gave the agent a prompt that will end up going and creating multiple agents, multiple tools for me. Rather than me having to create one agent, one task at a time, I'm having the agent to create the entire kind of plan for me.
Okay. In which case it would create a separate agent and a tool versus multiple tools that could solve the problem?
So in terms of the prompt engineering that I was doing, it depends all on my prompt. So if
Okay.
I specify one particular problem, go search the net for XYZ, then it will create one tool, one task. But the
Okay.
moment I start to add more functions, more capabilities, what's happening is that it will go through all these different elements. So
Okay.
very important to note, I can specify the LLM at the agent level, but I'm able to also specify the LLM at the
Orchestration.
that layer which I added on top of Crew AI, which now, if I take, for instance, GPT 3.5 Turbo, and I exactly ask that same prompt, it will not give me the same quality of the plan that I generated here. If I even go on higher thinking models, I would even get better quality in identifying the tools, identifying the actions that can be done. Now, the reason I chose GPT-4o Mini is I wanted to immediately show you a result and come back quickly to that result. But you could go quite fancy there as well. So what you see now in front of you is something that I could save as research agentic AI frameworks. So once I save it, initially it's not optimized. It hasn't been doing adaptation or learning. I could visit it later. So now I have my plan store, and within the plan store, I could go away. I forgot it. I could come back and I could pull up the plan that I've been working on, and then I don't need to lose anything. I have it always here for me. What also becomes important is I'm able to export all the plans and I have them in a JSON format. I'm able to import all the plans and I have them in JSON format.
Nice.
I'm able to share them with other colleagues. Other colleagues can look at them, can run them, can test them out. So let's run it. Enough talking here. So I'll enough technical. I wanted to say. So in terms of how we would be able to do it, I'm specifying now a tool, which is the SuperDev tool, for instance, which allows me to go and search online. So what happens next? Now I'm specifying that tool, and I could run that particular plan. Now, if I look at that plan is running February 25 AI papers review. For the technical folks, they could dive in the WebSocket. They could see that job running in the background, understand what's happening in real time. I have callback functions that immediately shows me every output of every task. So now I'm seeing all these different papers. I see the link of the paper, when they were published. I also see what I specified, extract the conclusion. So that was the conclusions from those different papers. And then in the end, identify which papers had the highest reference. And then I'm seeing some of the reference here across the different papers. Again,
Execution trace, is it MLflow tracing here, or is it some separate way of tracing things?
So that tracing is every task. I created a callback factory. And the callback factory is allowing me not just to trace the agentic AI trace, but it allows me to add my opinionated additional tracing capabilities that I wanted to have. So in terms of, I'm not using the MLflow trace. I built my own factory of traces that are happening there. And that helps me, for instance, to look into, so I have logging here, for instance, and that logging is, it allows me to trace all the different, before doing any action, it allows me to trace every log, every request, every answer. I'm able to basically have, I'll show you quickly what I have it here. I have basically this thing called loop callback factory. And this callback factory allows me to do many different validations that I have to in place, that I'm able to add additional functions for every output that goes in. And those could be functions that I could customize based on the organizational requirement that I have in place. Yes, so I'll stop sharing, just going back quickly on the tracing. So no, it's not just the ML flow trace, it's additional trace as well.
And in terms of the infrastructure, as in where does it run? What is it happening behind the scenes?
So in terms of the infrastructure, important to note that a lot of what we're having is powered by Databricks. So by the way, this is all, you have the model serving, and model serving is allowing you to call either the frontier model or the open source model or the traditional ML pipeline endpoint.
Okay, so then we have kind of external models linked to the agents, and also any other model serving endpoints serving classical ML models or any other AI tool someone has built.
Correct.
Okay.
You also have the AI gateway capabilities that you're able to connect through that. The entire thing, front end, back end, mainly can be deployed anywhere. But what I've built is I built it in Databricks apps. So you have the front end and the back end and the relational database all within the Databricks apps deployed there with an ICI/CD that is going to run your unit test, put it, bundle it all together, and then ship it to Databricks apps. ML flow, that mainly whenever you have RAG endpoints that you want the agent to be able to talk, so that will be able to leverage that piece. I don't use the tracing, and I'm not using the other capabilities. These are, think of them as you do them before you reach Kasal. So those are, you ramp them through your usual RAG implementation and fine-tune model approaches that you want to do. But once you have them, they will be using ML flow, and then these become tools for Kasal. Genie. And Genie, that's my favorite out of all the different tools that I'm having, because that's where now I'm able to say, Genie, go and figure out all the different tables, ask the various questions. And then now the agent is mandated with the goal, and the agent is able to ask all these questions. And Unity Catalog, the most important element.
Across everything. Yeah.
Because with Unity Catalog, think of it as, sometimes with Genie, you need to know what is the right table, and then you have to build the space before. And once you build the space, you have to curate the space, set all the instructions in the space. But what if we have, and hopefully soon, the conversational API with also the API to create the spaces? And what you could do is talk to Unity Catalog, figure out all the different tables and information that you can use to achieve your goal. Then let the agent create the space with the instructions, with the benchmarks, running all those different tests, then go and ask the questions, then give the summary, and then come back. Again, a lot of work, that's some idea, but that's hopefully where I would like to be going in that direction.
Beautiful. And I guess the next question is the project open source? Like, can people use it?
So at the moment, I'm working with the different teams. So there's a lab team, and we have an internal team that I would love to open source it. And we're just going through the logistics to make sure that everything is there. I don't have keys all over the place, and I'm following the best practices around it. So you asked me, how did I develop it? I leverage agents to build agents. So that was something that I wouldn't have been able to do it from September to now if I wasn't leveraging a lot of code generation there. So that was a big element of what I've been doing in terms of that. My 9-to-5 job, unfortunately, don't give me the chance to develop, and hence I needed to come with creative approaches to develop that. I myself have contributed to various open source projects in the past. Having the development background helps you accelerate, and that's the, I would say, story of leveraging agents for augmenting what you can deliver and what value you could drive. And that was kind of the story of how I ended up accelerating that effort.
Leveraging agents for building agents.
Absolutely. Yeah. And by the way, I'm not sure if you've noticed, but a lot of the slides that you see in front of you
Is Databricks app.
Yeah, it's Databricks. Well, it is code generated by agents.
Yeah.
So there is no longer slideware for me. And that makes my life much easier because I can write code. I don't know how to do presentations well with this nice design, but I know how to do the F3GS, and I know how to do some nice coding that will allow me to present my story better.
Neme, impressive.
Amazing tool.
Yes.
Well, we'll make sure to make it available in the video as soon as it's available for everyone to use. So it's very impressive. Thank you.
Thank you,
Thank you.
Neme.
Thank you. Excellent. Excellent. Thank you.